Yeah, good morning all. So today we are going to start our discussion with a new topic of number system, which is complements of numbers. So our discussion in the previous classes we discussed about how we can convert a particular number like hexadecimal into octal and decimal and binary and vice versa. So today we can extend our discussion to complement of numbers and we'll see what is it and why it is important to understand the concept of complementing the given numbers. So while no, if you remember in decimal systems, you might have heard about complements, no, or reciprocal. So you have a given a number n, and when someone asks you how to reciprocate the given number, then you say 1 upon n is the reciprocal of the particular given decimal number. But this is different with respect to the number system. What we are going to see here, it is not the case, and let's see what it is and why we need to learn it. So complements are used in digital computers or simply computers to simplify this subtraction operation. Okay, so when you have to subtract something from the given number, so you need complement actually. First, you have to know the complement of the given number, whether it is a binary number or a octal or a decimal. So actually, there is no basic operation like subtraction. What we do is we add a negative number into some other number, which is nothing but the subtraction in case. For example, if you know uh, a minus b is equivalent to a plus of minus b. Okay, so there is no difference. We know these two expression from left hand of the equal and right of the equal sign is totally similar. Okay, so you use complements for your computer to simplify the subtraction operation and for logical manipulation. And why it is necessary? See here, if you have to store negative number, you need a no separate kind of hardware. But then for addition, you have a setup which can add two numbers, which can be used for adding two positive numbers as well as one positive, one negative, or two different negative numbers. Then you will have no less hardware with your computers. And uh, from the starting of the digital systems, what no scientist does is they reduce the size of the computer, starting with the size of a room. Now we have a palm top in our hand. We have a mobile phone which can calculate all type of calculations. So better to no, we want things to be compact. So hardware size to be reduced, but the work done by the hardware setup should be more and more. That's why we need to learn the complementing and adding a negative number to a positive number, and or any kind of two numbers which is in negative, you can add it rather than subtracting only. So you don't have to set up a different hardware. Okay, so we are simplifying operation. Okay, so in this case we have actually no, we have two different kind of complements. Let's say we have radix r, then you can find r's complement. Okay, and r minus ones, r minus one's complement. So these two complement we are going to learn. So how do we find? Okay, so now understand, when we are talking about decimal number system, so you have tens and nines complement. When you have binary, okay, so when you have binary, then you will find twos and ones complement. And when you have octal, so you will find eights and sevens complement, and so on for hexadecimal also. Okay, so I hope you are getting the point. Now let's move and find a particular no complement and how we can find it. For binary it's too easy, but for decimal you know everything, but still you have to work on. So now let's have, for example, let me just clean it first. So we have a number called capital N. Oh, sorry. Let's have a number like something like N. Okay, please don't mind my handwriting over a digital board. Handwriting gets distorted. Okay, so given a number n in base r, okay, and you have to and this number is of uh, uh, n is of a small n digits. Okay, so for example, if you have number like 976, so you have 3 digits in this number. Okay, likewise we are generalizing the things. You have a number n in radix r, and you have n different digits for n. Then how can you find r minus 1's complement and r's complement? Okay, so r minus 1's complement of n is equals to r to the power n, which is number of digits on the radix minus 1. Okay, and minus the given number. Okay, so we have found, using this formula you can find r minus 1's complement. Now for example, let's have the number r equal to 10. So we are talking about decimal system. You have the number 102. Okay, so it's capital N equal to 102, so a small n will be equal to 3. So what is r minus 1 complement? So r minus 1's complement is nothing but 9's complement of 102 will be equal to r to the power n. Okay, let's write the formula once again. R to the power minus 1 minus capital N. So equal to, your r is nothing but 10. So 10 to the power 3 minus 1 minus n. So equal to, it's 10 to the power 3 means 1000 minus 1. So 999, and n is 102. So equal to 79897. So this is our answer. So 9's complement for the given decimal number 102 is nothing but 897. Using the formula you can easily calculate. So no, you got the idea. Okay, so we can proceed, and meanwhile I can give you some examples to work on. Okay, let me discuss. Yeah, uh, have some numbers and find the complement, so that you have the hands-on practice. Should I give the numbers? Okay, so work on the numbers like 9 1 2 4 3 5 6 7 1 8, and so on. For example, you can have your own kind of numbers also. Now let's go for r's complement. So r's complement of n. Okay, so let's go and find r's complement. So it's even easier. So you can have, let's say you have n digits again. No, okay, let me write here. It is an n digit number. Okay, so now you have r, so r's complement we are looking for. So its formula is r to the power n, so number of digits minus the number. Okay, so this is your r's complement. Or you can see what we did here is, just you can replace it with r to the power n minus 1 minus n. Okay, and plus 1. So when you add plus 1 in your what r minus 1's complement, you will get r's complement. But keep remember this thing, it is easier to remember. Okay, so r to the power minus r to the power small n, which is number of digits on the given radix, minus the number itself will give you the tens complement, or sorry, r's complement. So for example, if you have a number, for example we have a numbers, let's say again 102. So you will in 10, so your r is equal to 10, capital N is equal to 102, small n is equal to 3. So what is R means tens complement. So tens complement of 102 is equal to R to the power n minus n equal to 10 to the power 3 minus 102 itself. So you will get your answer as 1000 minus 102. So which is equal to 8 9 898. So if you remember, r minus 1 or 9's complement was 897 plus 1 is 898. You got your answer correctly. So for decimal, you have found the tens complement and nines complement. Okay. So this was the simple concept we have learned. R's complement and r minus 1's complement. But we have seen examples only with the uh, sorry. Uh, you saw the examples only with the decimal numbers. Why decimal? We have started with decimal number because we have a feeling for it. No, we have been learning it since our childhood, so this is just familiar. Okay, no, but our discussion will not stop here. We will mainly go for we are looking for two's complement. So let's start with the one's complement and two's complement. Okay, so for a binary number, so for binary numbers, let's find r minus 1. So binary numbers, so it is r's and r minus 1's means r's means 2's complement, r minus 1's means 3's complement. Okay. Okay, so you have now a number n. So how will you find r minus 1's complement or 1's complement? So 1's complement of n, which is of n digits, so you will find equal to, using formula, 2 to the power n minus 1 minus n. So you will get 1's complement like that, or 2's complement. Now you know the formula. Okay, so I should have asked it again. It is of n digits, so n is a binary number actually, no? So 2 to the power n minus n, so it will give you the 2's complement, and the left side one will give you the 1's complement. Okay, now let's have an example. Okay, so we have a number. Yeah, let's have our number n. So we are using 4 digits. So n is equal to a small. We are talking about a small n. So n is equal to 4. No, 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 no. Okay, just give me a second. Yeah, let me discard it first. So we are talking about a number. Let's have capital N is equal to, sorry, capital N is equals to 1010, which is a binary number, we all know. So how to find one's complement? Using formula. First let's go with the formula. So a small in is equal to 4. So you make, okay, let me write here, one's complement of one's complement of 10102 is equal to 2 to the power 4, because n is equal to 4, minus 1 minus n. N is nothing but 1010 itself. Okay, but let me know you, 1010 in binary is equivalent to 10 in the decimal number system. Okay, so because we are no, this operation has been done using decimal number system. You should be just changing your number system from binary to decimal. Okay, so 2 to the power 4 is nothing but 16 minus 1, so 15 minus 10 is equal to 5. So how will you write 5 in complement form? So 101 using 3 bit you will get 5, but you have to put an extra bit at the, because we had 4 digits, no, so I put 1 bit here, so it is 0101. So it is your ones complement. Okay, one thing I should know, tell you before the start. So all these no formulas work on the decimal number system. So whatever you are doing, first convert the given number into decimal, then convert in, then finally when you have something at the right hand side of it, so answer should again be converted into the binary, or whenever you are working with octal or hexadecimal, accordingly you convert. But first the given number should be converted before using the formula. Given number should be converted into the decimal number system. Okay, so it's a cumbersome task while you are converting a given number into decimal, then using formula. Okay, it will no make your mind heavy. So there we have a no easy process. Okay, let's see here. You have 10, you had 1010 was the number given to you, and you found the complement of 1010 as 0101. Can you see a pattern? Each 0 becomes 1, each 1 becomes 0. Okay, so whenever you have been asked ones complement of a binary number, what you should do is just invert each and every bit separately. You will get your answer. Okay, so uh, let me work on a simple process apart from using the cumbersome task of. So what you do, you have been given a number. For example, I gave you a number n, which is in binary, equal to 1,000,000. So one's complement of n should be, one's complement of n should be convert all zeros in ones. So 1 1 1 and all ones in zeros separately. So you will get 0 1 1. It is your answer. Okay. So one's complement is very easy, and when you have, let's say you have 1 1 1 0 as a number, capital N, just finding one's complement is a very easy task. So it will be equal to 000, because all ones will be converted into 0. Excuse me. Yeah. So this is our answer, 000 and 1. So one's complement was very easy. But if you remember how to find two's complement in the previous complements in decimal systems, how you got tens complement from the nines complement by adding 1. Okay, so whenever you have been told to find two's complement, so let's write, we have a number 0 1 1 1. Forget about the formula now. Okay, so we can directly convert from two's complement, from one's complement into two's complement. So we have 0 1 1 here, and is one's complement, let's say its one's complement will be 1,000,000. So just what you have to do is you have to add plus 1. So 10 is nothing but 1. So 0 0 1. This is your two's complement. Okay, now using formula, let's see what we get using formula. Just uh, uh, we are trying with formula also. So we have been given number as yeah, we have been given number as 0 1 1 1, and we have to find two's complement. Okay, for the given number. So the formula says it should be 2 to the power n minus n. So 0 1 1 is nothing but, in decimal equivalent it is 7. So but 2 to the power, how many bits was there? 4 bits. So 2 to the power 4 minus 7. So 2 to the power 4 is nothing but 16 minus 7. is equal to 9. How can you write 9 using 4 bits? So 1 0 0 0 will give you 8, but if you write 1 0 0 1, it is equivalent bit of 9. How did you do it? So 1 2 4 8, so 8 plus 1 is equal to 9. So using this also you can do using formula, but then if you use formula you have to convert the given number into decimal, then apply the formula, then when you get again your result, your answer 9 which is in decimal should be converted into the binary. But the easier process is first convert into ones complement using inverting each and every bit and then adding 1, okay, in binary form itself. Then what, which one will be easier, so using formula or not using formula? I obviously choose not using the formula. Okay, so this is the very easy task we have seen. So 8s and 7s complement, same using formula you can do whenever you have been asked to do a conversion of no given octal number into its 8s and 7s complement. What you have to do is first convert 8s complement into the decimal, then apply the same formula there by exchanging the r's and capital and small n's value. So this will work in all conditions. Yeah, so we are not going to discuss 8s and 7s complement. I hope in a generalized way using the formula you can do it. Okay, now now we will extend our discussion with how we add the numbers. Okay, okay, so one observation you could have seen, if you to know same number can be complemented two times, you will get the original number. For example, if you have given a number 101, take one's complement, again take one's complement will give you the original number itself. Okay, so complement of the complement give you the original number or restoration of the number. Okay, so now our discussion will be extended towards the subtraction using complement. So subtraction, so addition is very easy, subtraction with this one is also very easy, but discussion is because you want only one hardware to be used with the subtraction as well as addition. Means we have addition hardware and we don't want a separate piece of hardware for subtraction. So how can we utilize the same hardware so that we can get our okay? Okay, one question should have been asked. Okay, let's have 0. Okay, so 0 in binary number, 0 can be written as 0 in 1 bit. Okay, so when you have 1 bit you can write using 2 bits, you have 2 zeros, using 3 bits and so on you have 3 zeros. Okay, so 0 can be represented using like this. So one's complement of 0 will be 1 1 1 1 1 1 and so on. Number of bits will be increasing, you have to put invert each and every bit separately. But now comes here, so but in case of 2's complement, no, you will have two different okay, let's say this was one's complement of 0. Okay, one's complement of zeros, so what should be 2's complement? 2's complement of zeros, what we did is we have to add plus 1. So this is, so see 1 1, so you have a reminder 1 1 is 0, so one extra bit will be written here, so it's 1 1 0, so you have rest 1 here, so you add these two 1 1 0 and 1, so it will be written like this. So this is 1 1 0 1, so you have a 1 here 1 1 0, again you have a 1 here 1 1 0 and 1. Okay, So like this, you can find the for complement two's complement for zeros and one's complement for zeros. Okay, so don't worry about the one extra bit. It is called no. So you are carrying something. So you have generating a carry. Like you are adding 9 plus 1, you will get 10. So you have carrying 1 uh, for the next bit towards left. Okay, so for 0. But see, a number can be either positive or negative both. Okay, so for example, we can have uh, sorry, we can have plus 5, we can have minus 5. So you have for 0 also, we can have plus 0, we can have minus 0. But you know, plus 0 and minus 0 doesn't matter actually. These are two same thing. But while using one's complement, you have similar representation for plus 0 as well as. So in one's complement, you have only one representation for plus or minus 0. Okay, so only one representation. But in case of plus 0, we have a different two's complement, and in case of minus 0, we have a different two's complement for the same number, because plus 0 and minus 0 both are similar, we know. But two different two different things are considering for the. Sorry, I'm telling wrong here actually. Here we in case of one's complement, actually we have two different. Sorry. Yeah, okay, let me erase it. Yeah. So in case of two's complement, you have only one representation for plus and minus 0. But in case of one's complement, you will have two different notations for uh, plus and minus zeros. That's why uh, two's complement is favored with respect to one's complement. Okay, your hardware, your computer hardware, your any digital hardware is designed for representing numbers, a negative number, using two's complement rather than one's complement. Okay, so one's complement and two's complement are nothing but a it is used for the subtraction. But how subtraction can be done? Using representing a number in its negative form. Okay, so the main purpose of complement form of the given number is to represent that number into its negative form, because for positive there is no problem, but for negative we have several different notations to be used, how a negative number can be effectively stored in your hardware. So that's why we have to learn, or we should learn the uh, complementing a number. And it is, this is the reason it is important. So now let's start our discussion of subtraction with complements. Okay, so no, while learning in our elementary education system, you have the borrowing concept. For example, if you have 9, so if you have 91 minus 60 56, so actually 56 is nothing but minus 56. Okay, this is the not the operation, but the number itself is getting added with your the operation. Anyway, just forget about it. Just we are now decrementing 56 from 91, so you have to borrow. You have borrowed from 9, so it becomes 11. So 11 minus 6 will get fetch you 5. Now it becomes 8 because you have borrowed 1. So 8 minus 5 gives you 3. So your answer is nothing but plus 35. But in another sense, if I say you didn't subtract but you add, it was 91 plus negative value of 56. Okay, so answer will be again plus 35. But we have changed the operation. Here the operation was the subtraction operation, but here the operation itself is the addition operation with a negative value. Okay, so yeah, why it is important is because you want your hardware to be low. Okay. So okay, now we can proceed discussing using, because now we have the idea of one's complement, two's complement, radix, the number of digits in a given number n, and so on. So let me uh, sorry, I should always choose the one, but I sometimes forgot. The subtraction of uh, two n digit unsigned. uh, Unsigned means all positive numbers. Okay, unsigned numbers m minus n. Okay, in base r, base or radix. Okay, both are similar. Base r can be done as follows. So I am telling you the method of subtracting two positive numbers. Okay, so this is the operation now. N, m, and n are positive numbers. Earlier, what we did was different. So, but let me be with me and okay. So add the minuend m. Okay. So left part of the minus operation is called minuend, and right part of the minus operation is called subtrahend. Okay. Let's see. So m to the r's complement of the subtrahend n. Okay, so mathematically you can write it m plus r to the power minus n. Okay, or we can write it m minus n plus r to the power n. Okay, so this is the one way, the first step of, not one way, but the first step of uh, performing subtraction of two unsigned numbers. I am keep repeating the word unsigned is used for a non-negative number. Okay, the number which is here, you don't understand that n is a negative number. Actually, this is an operation which is called subtraction to be performed on two non-negative numbers, which is m and n. Okay, so let me write the next or second part of doing the operation subtraction on two unsigned numbers. So now what you have to do, okay, so let me choose the blue color. Okay, yeah, so if m greater or equal than n, the sum will produce n and carry. Now I will introduce you and carry r to the power n, which can be discarded. We cannot consider it. Okay, so we should ignore it. So what is left is the result, sorry, the result m minus n. Okay, now it is telling you if the minuend, which is the m, so left side of m minus n was, okay, so it was m minus 1 actually firstly. So if m is greater or equal than n, so the sum will produce an end carry which is says r to the power n, but we should discard it. And the final what is left after discarding the and r to the power n, which is a carry, is a result of m minus 1. For example, m is sorry, let's say 7 minus 5. So minus was the operation and 7 minus 5 should be performed. This is an operation. This is an operator. Okay, just think it is an operator and two different positive numbers have been given to you. So your answer is 2. So we are not considering any carry because m was greater than n. So whenever left hand side is greater in the subtraction operation, whatever left after the operation will be your result. Then we have the second point we have seen. Third point and second condition of it, when n will be the greater, okay, or upper hand will be the greater. Third point says if m is less than n, means left number is greater, the sum does not produce an end carry. So there is no end carry is produced, okay, and is equal to r to the power n minus m, okay. So which is the r's complement of n minus m. So whatever result you will get after doing this will be nothing but r's complement of n minus 1. Now you can easily think, how did we calculate the complement, r's complement? The r to the power small n minus the number itself. So now n minus m is a number, so you are just subtracting the number from its base to the power n, and small n is the number of digits in this number. So you are actually calculating r's complement of n minus m, okay. So now still we didn't get our answer whenever n is small, so we have one more step to obtain the answer in a familiar form. So take r's complement of the sum and place a negative sign in front, okay. Now we'll see an example and you will get all these points. But I suggest you to write these points once by yourself, and then see the example, okay. So let me just uh, erase it, and we will have the examples where we have the clarity, okay. So with the given examples, so now, yeah, so questions will be asked like that, using, sorry, using tens complement, subtract 72532 minus 3250, okay. So now have our m as, so m is equal to nothing but 72532, so n is equal to 3250, and what we have to do, our operation is minus. So it is a binary operator which needs a negative value in the left side, sorry, an unsigned number at the left side and an unsigned number at the right side. So we have our m and n. So first step, if you remember, what will you do? You have to 72532, so add, okay, using, now we have to take r's complement of n. So n's r complement, एन आर कॉम्प्लीमेंट को आपको ऐड करना है। एन की आर कॉम्प्लीमेंट क्या होगी, 4 डिजिट्स हैं इसमें, तो 10⁴ minus 3250. If you remember, this is the, so 10⁴ is nothing but 10,000. 4 zeros minus 3250 will give you the result as 0 becomes 0, 10⁵, 10 minus 5, 9, sorry, 9 minus 5, it should, yeah. So 0 0, 10 minus 5 is 5, 9 minus 2 is 7, and then 9 minus 3 is 6, and then 9, 10 minus, okay, then left is nothing but 9 itself, because we have borrowed from this one, so this becomes 0. Okay, so yeah, 96750. If we add 250 into this, it will become 9700. Sorry, 97,000 plus 30,000 will become 10,000. Yeah, so it is our complement of n's, or n is nothing but 3250. So we are adding as a first step. It was told whenever m is capital, you have to add the given complement. So it is telling you using r's complement. So add it, 9, 6, 7, 5, and 0. So what is the answer? So 20235 is 8, 75 is 12. You have borrowed 1. So 213639, and 9 plus 6 is 9, 7, 6, 15, and 16. So 169282. So discard and carry. So you have tell you have no, you will get an and carry which is equivalent to r to the power small n. So you have to discard it. So if you remember, it has 5 bits. Your m has 5 bits. So its carry should be equal to r to the power minus 10 to the power 5. So 10 to the power 5 is nothing but आपको घटा लेना है इसमें से. तो 1 2 3 4 5. So our answer will be the 2 8 2 9 and 6. 69282. Okay, so this is our simple answer of m minus n. Now or see here, look here, we had only 4 digits in the n. So you can have a put a 0 here also, so it is not going to affect in any case. You will get your answers easily. Okay, so you should have equal digits while performing this kind of calculation. So अगर मैं यहाँ पे एक 0 पुट भी कर देता तो कोई अंतर नहीं आता आंसर में, बस 5 डिजिट में आंसर आना चाहिए था, जो कि आ भी रहा है. ओके, so taking tens complement of n produces a 9 in the most significant position. The occurrence of the n carry signifies that m greater or equal than n, and that is the result. Therefore, positive results we receive because m was greater or equal than n. Now we will see an example where m will be the less or equal than n. So whenever in exam you will ask to do, you have to perform all these steps whatever given in the previous algorithm. Otherwise you won't get full marks. Anyway, we are not going to ask you in decimal. Maybe I will be asking in binary. So you have to work on it. Yeah. Now again the questions change slightly. Using tens complement, subtract, the position of number has been changed. This time you have 3250 minus 72532. Okay, so your m is here, your n is here, so you can have an extra bit as 0. There is no problem by doing this. So remember the second part of your algorithm. What does it say? If m less than n, this sum does not produce an end carry. Okay, sum is not going to have an end carry, so we need not to discard it. Okay, so what was equal to r to the power n minus n minus n. Okay, so you have to perform that operation, which is nothing but was the r's complement of n minus n. Okay, so now टू अपने आंसर को आपने क्या करा था, इसका फिर से एक बार आर्स कॉम्प्लीमेंट लेकर अपने सम का आर्स कॉम्प्लीमेंट लिया आपने दोबारा, और एक निगेटिव साइन उसके सामने आपने रख दिया, तो आपका आंसर आ गया. ओके, सो यू हैव लेट्स मेक इट. सो वी हैव m which is equal to 0 3 2 5 0. Okay, whenever you have so I'm directly writing, but you should work on it. Tens complement of n. Okay, so it will give you 27468. so you know the procedure, r to the power n minus n. so अगर आप इसको लिखना चाहें तो 10 to the power 5 minus 72532. जब आप इसको करेंगे तो आपका ये आंसर आएगा. ओके, सो हमने इसको ऐड करा, तो हमारा जो सम आया वो कितना है, सम इक्वल टू Yeah, it is 8, then 1 7 0 3. ओके, सो 8 4 बचेंगे, बाकी 4 3 7 7 3 10 2 1 3. या इट इज करेक्ट. देन फाइनली देयर इज नो एंड कैरी, सो व्हाट यू शुड डू, इसका फिर से आर्स कॉम्प्लीमेंट निकालना है अपने को. आर्स कॉम्प्लीमेंट इसका निकालोगे तो सम का कैसे निकालोगे आप, तो 5 डिजिट्स हैं, इसका मतलब 10 टू द पावर 5 माइनस 30718. तो 10 की पावर 5 लिख लेते हैं एक बार, 3458173. ठीक है, तो 10 में से 8 माइनस करा तो 2, 9 में से 1 8, 9 में से 7 2, 9, 9 में से 3 6. और इसके आगे क्या बोला हमें लगा देने के लिए, तो हमने निकाला आर्स complement of sum is equal to 69282, but our answer is nothing but by putting a minus symbol of 69282. So this is your answer, minus 6,92,082. Sorry, 6,09,000 69,282, and this was because your m was less than n. So second condition also we saw. In case of every numbers, either being it a decimal number or being a what do you say, being a binary number, the process should be same. We will have an example with a binary number also, don't worry. So here we saw the using decimal number, but next example is with binary number also. So let's say we have two binary numbers. Binary numbers as let's say x equal to 1 0 1 0 1 0 0 and y equal to 1 4 times 0 and followed by 2 ones, two number. Then we have to perform subtraction. So a x minus y, b y minus x. So one is the case when we have m greater than n, greater or equal. Another case is m less than n. So both cases we will see. So let's solve for the first one, which is x minus y. Okay, so how will you proceed? So you can see the position, most significant bit is 1 in both cases, second most significant is 0, third most significant bit of the x is 1 and it is 0. So here itself you can decide, so x will be the greater than y. Okay, अगर आप डेसिमल में कन्वर्ट करके देखना चाहो वो देख सकते हो, बट पोजीशन अगर देखें तो याद कीजिए आपको लिखना क्या है, 1 2 4 8 16 32 सॉरी एंड 64. तो ये नंबर क्या हुआ, डेसिमल इक्विवेलेंट 64 प्लस 16, सो 80 प्लस 4 84 is equal to 84, and this one will be 1 1 2 1 3 3 and 64, so it is 67 only. Yeah, so x is greater than, so just I said for example, but you can directly say that x is greater than y. Okay, so yeah, so whenever it was greater, you should have taken the 2's complement of the second number and finally add it. So you have been given x as 1 0 1 0 1 0 0, then finally you have 2's complement of y. So 2's complement first, okay, let me write here y, 1 4 zeros and double 1. So पहले 1's complement निकाल लेंगे, 1's complement में 0 1 1 1 1 0 0 और इसमें प्लस 1 ऐड कर दिया तो आपका 2's complement निकल जाता है. तो प्लस 1 0 1, देयर इज नो कैरी, सो बाकी सब बिट को एज इट इज उतार दो आप. Okay, so this is your 2's complement, so write it here. So 0 4 times 1 then 0 then 1, इसको ऐड कर लेते हैं. तो सम जो निकल के आएगा फिर उसको उसमें से डिस्कार्ड कर देंगे टूज कॉम्प्लीमेंट, सॉरी आर टू द पावर एन को, मतलब 2 की पावर कितने बिट हैं इसमें, 8 बिट्स हैं, 2 की पावर 8 आपको डिस्कार्ड करना पड़ता है। तो ऐड करो 0 1 1 0 0 0 1 1 0, एक कैरी यहाँ पे गया 1 1 0, फिर से एक कैरी आई तो यहाँ पे आ गए। सो 1 1 0 एक कैरी आ गया और 0 1 1, तो 1 1 0 1 1 0 और एक एक्स्ट्रा 1 आ रहा है अपने पास, ठीक है, जिसको कि डिस्कार्ड करेंगे अपन। So our answer should be in the 8 digits only, but we got our answer is, let me check once whether it is correct or I forgot something. So it was 0, 4 times 1, 0. So 2's complement was okay for y. So we got 1, then 3 times 0 from right to left. Then it should be 1, okay, 0, 0. Sorry, this is okay, no problem. 1001 0001. Yeah, sum is here. We have now we have to discard. So discard and carry. So and carry is nothing but 2 to the power 7 because 8 bits are in a total. So 8 carry को डिस्कार्ड करोगे मतलब आप इस पोजीशन पे 1 रखो, बाकी सबको 0 कर दो, ठीक है। जब आप ये करोगे तो जो आंसर आएगा वो आपका आंसर होगा, और x माइनस वाई आंसर आपका जो आएगा, तो 1 में से 1 1 0 0 0, यहाँ तक कोई दिक्कत नहीं है, फिर 1 फिर 0 0, ओके। ये एक्स्ट्रा जो कैरी थी हमने इसको डिस्कार्ड करने के लिए ये वाला स्टेप लगाया, जो कि अपने एल्गोरिदम में भी लिखी हुई थी, फर्स्ट स्टेप ऑफ द एल्गोरिदम। तो अपना फाइनल आंसर यही आ गया, ये क्या है अपना, ओके। या नेक्स्ट इज द पार्ट बी वेयर n is less than m. Okay, sorry, number should not be deleted. Part B or part B, here y minus x should be done, and we know here m is less than, okay. Yeah, so what we have to do, write the y. So it was 0 1, sorry, it was 1 0, 4 times 0, 2 times 1, so we have 7 bit। x के बदले क्या रखना है अपने को यहाँ पे, 2's complement of x। so 2's complement, now you can calculate directly, 0 1 0 1 1 0 0. How did I do that? Just have a look. So you have 1 0 1 0 1 0 0, okay. You, okay, just convert it into one's complement. Let's get a step by step। one's complement करा तो हर बिट को सेपरेटली इन्वर्ट करा, 0 1 0 1 1 का 0 0 का 1 1 का 0 0 का 1 1 का 0 प्लस 1 कर देते हैं, ठीक है। तो 1 1 0 कैरी गया यहाँ पे, फिर से 1 1 0 कैरी गया वहाँ पे 1 0 1, फिर 1 0 1 0, यही अपना आंसर है, 0 1 0 1 1 0 0, ठीक है। तो आप ऐसा कर सकते हो। जो सम आया फिर से सम करें इसको, 1 0 1 1 0 1 0 1 1 0 1 1 0 0 0 0 1 1 1 0 1। यहाँ पे क्या करना था, इसका फिर से आर टूज कॉम्प्लीमेंट या आर्स कॉम्प्लीमेंट लेकर निगेटिव साइन लगानी थी। तो इसका आप टूज कॉम्प्लीमेंट फिर से एक बार ले लो। तो पहले वंस कॉम्प्लीमेंट आप करोगे तो 0 0 0 0 1 0 0, ये तो वंस कॉम्प्लीमेंट हो गई। टूज कॉम्प्लीमेंट के लिए इसमें क्या करते हैं, प्लस 1 कर लेते हैं। तो 1 0 0 0 या इट्स 1 0 0। ये अपना टूज कॉम्प्लीमेंट आ गया और इसके आगे निगेशन का साइन आप लगा दो तो यही आपका आंसर इक्वल टू आप लिख सकते हो -0 0 1 0 0 1। So this is your answer. So simple. Yeah. So we have seen the using decimal, the subtraction of two unsigned numbers in the decimal number system as well as in binary number systems. I hope you got the idea. What I suggest you to work on any two given numbers, and at the final you cross check your result with your decimal number knowledge. Okay, because we have the ability to understand the decimal only, but you have to interpret other number systems. So using the formula you have to perform it, but then verify your result using the idea of the decimal number representation. Okay. So yeah, so subtraction of keep remember, though you are writing y minus x, but these y and x are both non-negative numbers, and the minus is an operation you have to perform on these two numbers. So these two numbers are called operands, and the minus sign is called an operator. So it is a binary operator. Why? It is taking minimum two. Sorry, binary operator means two different operands need to be given to the operator. Then only you can perform the operation. Okay, so yeah, you have seen R using R's complement, but you can do it using R minus 1 complement also. But as you saw in binary number system, we have two different representation for zeros using one's complement. We avoid that because then again we should have an extra register in our system to understand negative zero and positive zero. Though it is not necessary to have a representation for positive and negative zero because both are similar. That's why we use only R's complement to perform this kind of subtraction. Okay, so and you see end around carry you have to remove from the first part where x was or m was greater than n, and you need to perform an R's complement of your sum value when you are when your n minus sorry n was greater than m or m was less than n. So I will end my discussion for today's class here only. All the best for the examinations. So you have, I will ask the questions regarding this point in tomorrow's exam. I hope you all will do well in this examination. And those who joined this no section later, you also going through the. If you are going through the subject already, then it's okay. Otherwise, we will see in future how can we give you an extra chance to improve yourself in the next midterms. Okay, so let's stop for tomorrow. Sorry, let's stop for today, and we will meet tomorrow. Thank you.